And we're live. Good morning. Happy Mother's Day, everybody. Make sure you guys can hear me loud and clear. Let me know. Give me a thumbs up. Like I said, I'm playing with a new mixer, so let me know the audio is good. And yeah, how's everybody doing? Aaron, Jason, my love, Courtney, Dan the Man Sutter Home just popped in. What's up, buddy? Oh, you have a flight. Right on. Gotta finish getting ready and spending time with the family. You bet, dude. Happy week to you as well. Good stuff. Where are you flying off to there, buddy? And how's Mr. Aaron Banks and Jason Reynolds? You guys are good? Thanks for popping in, man. No, seriously, if you need me to turn my audio levels up, let me know at any time. I'm going to play the music again today, so if you can't hear the music, let me know. Hi. So, yeah, dude, so we have, we're talking about, I got some pretty cool new materials I've found. We're going to be looking at some neat stuff. The reason why there's the Space Center, for example, on my thumbnail is because we're talking about one of the materials in particular, which is translucent or transparent aluminum, was what was used to make the windows in the Starship Enterprise, right? So it used to be science fiction, now is reality, right? So good morning, Suhana in the house. Good morning, everybody. Good morning. Happy Mother's Day. Guys, it's some pretty neat stuff. Like, we know everything that we know about construction is about to change. If you guys look back to how industry, manufacturing, and everything has changed over the last couple of decades, even since the 80s, right? Things have changed a lot. Manufacturing is all automated, and like the construction industry is the last industry to adopt to the new technologies, the new processes and ways of doing things, right? And that's because of the actual tech wasn't there. But now with the 3D printing and the new materials or even not just even new materials, but new ways of using materials so that they're stronger and more durable and better, more fire rated, we can build now higher, right? And higher with materials that you never would have thought before. And we can also build lower in a sense that we can now build underwater, miles underwater. Yeah, go check out Suhana's channel. She's another creator. Get subscribed to Suhana as well. She's got a really cool channel. So get over there and get subscribed to her. And yeah, I'll let you guys know. Man, oh man. Whew. Wow, it's been a growth fest lately. Like, been doing a lot of networking. Met so many new people. It's been crazy. Like, wow. So yeah, that's Tree Tremor 82, I believe. That stream has been like crazy off the hook, right? We've just been doing some mad networking over there, and wow, some of the channels, like people that we've met, is awesome, just awesome. So it's nice to meet new people, and it's like when you go to, like, say, Video Marketing World or VidCon or something like that. That's all that is, right? Is a big networking session, right, where creators get together, meet one another, share ideas, right? So this is what social media is, right? It's networking. So it's been awesome, guys. Been busy as hell, but it's good. So but yeah, guys, so yeah, like I was saying, building underwater, or building the elevator to the moon, the crazy things like that, right? So you gotta have like the traditional concrete and iron and brick or mortar ain't going to do it, right? Actually, concrete even is changing itself, right? The materials themselves are changing and advancing. Concrete is changing to self-healing concrete, right? Which is insane because of there's the nano strains, right? That when they're touched by water, expand, right, and fill up little tiny cracks right now. But that's why it's only used in like specialty artwork pieces or installation pieces at the moment. But in a mass scale, it could, like, seriously make buildings in concrete last for like like hundreds and thousands of more years, right? Like, it's insane. With the self-repairing concrete, it's insane. At any time during the stream, let me know if you want a link. I'll drop it down in the chat, or if you're on the replay, let me know. I'll send you a link in the comments, and no problem at all. I'm just not posting them in my descriptions anymore because they're just too many links, too many external links, right? Taking you outside of YouTube, and that's not good, right? I'm gonna put the audio on for a bit. I want to test out the music. I want to make sure my audio levels are good. Like, let me know. Do I have if I talk off to the side like this, or are you still hearing me, or do I I mean, I know it's gonna be better when I'm right on, but a lot of times I'm moving around. I'm looking at a different screen. And I'm not. No. Oh, you say hi. Say Amelia's gonna say hi. You just woke up. Say hi.
Hi.
Okay. I love you. Go upstairs because it is stinky. Okay. Go upstairs. Okay. I love you. Oh, you're just putting them? Right on. So the only way I really know is if I go back and watch the replay. Like, I can hear myself in my earphones now. I'm just not sure. I have to get the feel for how it transfers over live stream, right? So I'll go back and watch a few live streams and see how that goes, right? But I can easily turn up the audio on the music or on my microphone, no problem. First thing I'm going to do is I want to make sure this audio is all the way up, right? I don't know why this audio always starts down. It's okay, sweetheart. Let's play some Popski.
Yeah, I just put papers in my room.
All right, baby. So I got the music going. Make sure you guys can hear that. And if it's too loud, I can turn the music down. Like, as long as you're able to hear my voice over the music, we're good. So, woo-wee! Happy Mother's Day, man. Today's like the busiest day of the year for my parents in their restaurant, right? And man, it would be awesome to be there with them right now. I keep thinking, like, man, we have to raise our children so far away from family that, I was so lucky when I was growing up. I had a lot of family around. And my kids don't have that, right? They're just so far away, right, Mom and Dad? Awesome, Aaron. I appreciate the feedback. Thank you so much. And let's get into it then. We're going to start with a video on a YouTube video. It's going to be on the 9 construction tech trends to watch in 2019. We're going... Good, Jason. Thank you so much. Thank you. Good. The new mixer is awesome. Like, I'm just playing with it. I don't want the audio to clip out either, right? Like, boom, boom, boom. So I know I got to watch my certain letters, my certain like P's and stuff like that. I was listening to my playback the other day, and it was great. So we're gonna jump over to Sunday stream, the Sunday stream screen. I still haven't done my new intro yet for Construction Kronies. I still haven't finished my Adobe After Effects courses, so once I get that done, I'll probably finish them today, maybe. It depends if it's Mother's Day, so I got things to do, but hopefully I can finish that today and get working on my new intros and lower thirds and stuff for my videos. But yeah, guys, it's going to be exciting. Okay. Oh, there is one subject I'm going to be talking a little bit more of than all the other ones, and we'll find out what that is right after this stream. But it's called optoelectrics. Okay, optoelectronics or optoelectrics technology, something like that, right? So it's gonna have we're gonna be talking a little bit more in detail about that, which is gonna be awesome for the future. You know what I mean? Good morning, Christina. Happy Mother's Day. Happy Mother's Day, Christina. And where? Oh, dumb. I hate that when I go to my Streamlabs screen and use that remote control.
Twins, the robots.
Look at that. There's the robot drywaller.
Wearable tech,
Yeah, even the materials themselves are going to become more intelligent, right? What they were showing is the facades, right? The material that actually eats pollution. All right, so I'm gonna pause that. I'm gonna pause out the music because I want us to be able to hear this video. Hopefully that.
Rapidly moving from science fiction to reality, robots are beginning to enter construction in a number of areas.
I guess, sorry, I should say the reason why we're starting with this video is because I want to. You have to understand the certain technology first, like before we get into the material side of things, because that the technology and the processes of doing things or the technology that we use to do things are going to change, right? So it's very fascinating. Like the whole of construction is going to change. There is also a new AI is freaking you out. Yeah, right? There's been some advancements in AI.
Increase the efficiency and detail of site inspections, to mechanical arms that automate highly repetitive tasks like bricklaying and tying rebar. The robotic revolution looks set to gather significant pace in 2019. While the credibility of robots on live construction sites has long been questioned, the last 12 months saw a number of real-world trials deliver their results, and the unveiling
this guy's
of some
going to replace me, right? This is the Japanese drywall robot.
Now taken seriously, the debate has moved on to how best to integrate robots, the impact they will have on existing job roles, and the new skills that will be required as processes become automated. Building on this progress, the rise of artificial intelligence is also beginning to have an impact on construction.
What? That's insane.
From the major leaps taken in concepts like predictive design at the project planning stage, to the rise of intelligent buildings that learn how best to operate themselves and serve their users over time, the construction sector will likely find itself at the core of the wider AI debate taking place across our societies in the year ahead. Though fraught with challenges and inherently disruptive, the rise of automation could give construction the efficiency, productivity, and safety breakthroughs
that's all I have to say. That's
sought for
really
decades.
Not cool. Oh man, that's really freaky deaky.
Originally developed for military use and for patient mobility and rehabilitation.
Oh yeah, we've seen these guys
are now
before.
beginning to appear
Lots of
on
this stuff we've seen.
construction
That's
sites.
why. If you're a regular here on the channel,
workers from manual
you're going to have
handling
seen a lot
injuries
of these
and
stuff
the
in this
risk of
video.
hand-arm
That's
vibration.
why I want to kind of
These
recap
mechanical
what we've been
suits
looking
that
at
augment the
right
human
before we go
operatives
into the
can
into
also
the
deliver
materials,
considerable gains in
because like I was saying, things are going to
Already
be
being
automated, and
rapidly
AI
adopted
is
across
going to be
manufacturing,
operating in ways that
live
you might
trials
not
on
expect it
construction
to.
sites in
But
the
I'll
past
get
year
into that.
have yielded results that look set to drive the development and uptake of exoskeletons in our sector during 2019. Connected job sites use cloud technology to make information about almost every aspect of their operation available to all the relevant parties, regardless of whether those parties are on site or elsewhere. From putting design information streamed from a single point of truth into the palms of operatives, to information by geolocation, remote site monitoring, personnel location tracking, live markups, and the seamless transfer of as-built information.
It will, Christina,
Connected
they will.
job sites improve communication, productivity, and safety for everyone involved in a project. With the intuitive technology supporting these sites advancing and now more widely available than ever before, connected job sites are only expected to become more commonplace in 2019. Meanwhile, developments continue to be made in connecting people and consolidating systems through digital mapping engines that contain and visualize construction data. New technology like Bluebeam Atlas, set to be available in 2019, is leveraging geospatial mapping to rethink mobile information access.
Okay, so thinking about
Mapping
this, right?
design and construction data onto a real-world job site, Atlas uses geolocation to present project information from multiple systems
Bluebeam's
relevant
actually
to your
amazing.
physical location. making traditional folder structures obsolete and streamlining any access-critical process like snagging, inspections, and more. While autonomous vehicles continue to make headlines in the consumer space, their adoption in the construction sector looks set to take notable strides forward in 2019. As with the field of robotics, the automation of construction plants, particularly in relation to highly repetitive tasks, could greatly improve productivity whilst creating a safer work environment and helping to address the industry's shortfall in labour.
Wow.
At their electric site in Sweden, Volvo Construction Equipment trialled electric autonomous vehicles in conjunction with electric human-operated excavators to deliver a 40% improvement in efficiency.
Oh yeah, Jason, it will happen. It'll happen because the material themselves is going to
include semi-autonomous electric excavators
the materials that
can
they
learn the
use
careful
are
movements
going
required to achieve grading
fix that
or
problem.
highly accurate
And
leveling.
the environments are going
use
to be
of autonomous technology
averaged
and
and leveled
power
due to
enables
personal
work to take
preferences
place
of the people
around the
inside the
clock
spaces, right?
without the need for brakes
that's
or the disruptive noise
Nest Home
levels that
thermostat, for
traditionally
example,
prevent
learning
such
thermostats
working.
and things like that. Like if you
Meanwhile,
go to say
Volvo's
Bill Gates'
trucks
house, you get a
business
little
has made progress in
little pin
developing
or
a
whatever,
concept
and
fleet
you
of
wear it
fully
around.
autonomous
And the
electric
rooms that you
vehicles
walk into will
that can
adapt
help
to your
combat
climate.
pollution, noise,
That's
and
going to
congestion
happen
in
in
our
every
cities
building. That's going to
by
happen
reducing
everywhere,
emissions,
right? So
planning optimum routes, and responding
the
to
level of
real-time
autonomous
traffic situations.
like autonomy in these in what's in construction, that's what's going to happen is in very crazy
With
crazy
growing
scary
awareness
things for
of the
people
impacts that
who
construction
are in the
has
trades.
on
Like
our environment,
you're gonna need
technological
to
advances are bringing
you're
numerous
gonna if you're
new
older,
material
like
innovations
you're
to
gonna
the
need
fore.
you're gonna need to learn
The
something
recycling
new.
of
Things are
hard-to-dispose
changing,
of
and
waste
they're gonna change
products
so
has
quick.
seen a
They're
significant
gonna
increase,
change right before our eyes.
particularly in relation to plastics. Recent developments.
Yeah,
have seen the
I think so,
incorporation
Christina.
of
Yeah,
waste
definitely to
plastic
keep
into
people
roadways,
awake and
even its
working.
use
Yeah,
as a material for 3D
yeah,
printing
it's
new building
always about
components or
productivity.
structures.
That's for sure, right?
CO2 is another byproduct.
But I don't
being
know because I've never heard
repurposed
that
in an
before
effort to
either.
reduce the carbon
But it could make
footprint
sense,
of the
Jason.
industry.
The
At
what
this
you're saying
project in
about germs and
Atlanta,
viruses.
CO2 is injected into the concrete mix used in the building's structure. This carbon dioxide becomes trapped inside the concrete as it cures.
Yeah,
while
I
chemical
couldn't do
reactions
office work.
within the mix
It's
form
not for
limestone
me.
nanoparticles that increase the overall compressive strength.
Right,
of
so
the final material.
nanoparticles.
Staying with one of construction's most popular materials, self-healing concrete is mixed with calcite precipitating bacteria.
Yeah, so stuff.
These bacteria germinate when water enters the cracks in
There you go.
decaying concrete, filling the emerging air gaps.
Neat,
Other
right?
areas to watch include the continued rise of kinetic paving that harvests energy from the footsteps of pedestrians to generate electricity,
Amazing.
4D printed structures that have the ability to reshape or self-assemble over time by virtue of how different elements of their construction respond in different
Amazing.
conditions, and smog-eating buildings coated
Right.
in photocatalytic titanium dioxide that reacts with light to neutralize pollutants in the air of some of the world's most congested cities.
Incredible, incredible.
Unmanned aerial vehicles, also known as drones, look set to become increasingly common on construction projects throughout 2019. From undertaking inspections, ensuring that operatives are kept out of harm's way, to surveying vast areas of land in just a few minutes, the continued rise of UAVs will considerably improve safety and productivity in construction. In a similar vein to robotics and the rise of automation, debate in this field has matured from one around feasibility to considering the steps needed for successful implementation, with safety, approvals, privacy, the need for suitable legislation, and the urgent demand for specialist skill sets all on the agenda. While virtual reality, or VR, has traditionally enabled project teams and stakeholders to step inside their proposed schemes before construction works commence, the technology is finding countless new applications.
Yeah, that's
across the
actually a good
industry
idea, Christina.
as 2019
those
dawns.
like those
From
conferences and
enabling
stuff like that
walkthroughs
are...
of complex site logistic plans
Whoa,
in
did you
advance
see that? Sorry,
to
but,
supporting
like,
health and safety awareness training,
that crane setup was
VR
pretty
use
crazy.
has matured in construction and made a largely successful transition from its early days of novelty into a number of practical uses. In hardware developments, HP's virtual reality backpack PC allows VR users to enjoy a more realistic, untethered experience,
Whoa.
adding to authenticity and improving outcomes. Meanwhile,
How did I miss that
developments
yesterday?
continue to be made in augmented reality, or AR. The technology provides a digital overlay of our real-world view, offering a range of data to site personnel, from design information to statistics on productivity and health and safety warnings.
Yeah, 3D
The use of 3D printing technology is advancing rapidly in the construction sector at all scales. Accurate digital design information allows 3D printing to be used for everything from rapid prototyping, component manufacture, and scale modeling to the full-scale printing of house and bridge components.
Right, look at this. That's what I mean.
With a
Even
number
the
of
design will
prototype
change,
structures
right?
completing in the past year, countless larger trials proving successful, and ambitious plans to 3D print entire housing districts in development, 2019 looks set to be the year that 3D printing moves from the fringes of construction to become a credible structural solution. The construction industry shapes our world, affects how almost every person on Earth is able to live their lives, and enables the majority of other businesses and service sectors to operate. In that context, ensuring that the built environment is operating as effectively as possible is of critical importance to the sustainability and successful development of the human race. By harnessing the data from the digitally enabled built assets we are now creating, our homes, offices, and in turn cities can all be operated in a smarter, more efficient, useful, and environmentally friendly way. Furthermore, the data arising can be used to assess trends and to inform the design of future buildings, infrastructure projects, and even large-scale city-wide master plans. With the effective development of our urban environments
scale of it,
on
right?
the agenda of countless governments and authorities around the world, we expect to see the importance of this area increase significantly in 2019. If you enjoyed this video and would like to get more from the definitive video channel for construction, subscribe to the B1.
Yeah. So it's pretty crazy, right? Like we're going to be seeing like things change, like the connectivity of it all, right? So the autonomy. This is the thing, right? So the not only are things going to be autonomously built, right? Like they're going to be designed and planned automatically as well. The thing we keep thinking about the one building that we're doing, the one project that we're doing, and not the bigger scale, right? Like the city-wide development, things like that, right? These machines, like did you see the Bluebeam Atlas that connected? It was literally had like a globe per se. Okay, hey Eddie, how's it going, Eddie Smallhorn? Nice to see you. And Courtney is popping in and out. I'll let her know for sure if she misses that. But thanks for coming, man. Nice to see you, buddy. So like the Bluebeam Atlas, right? So think about this, right? So you pull up the globe on your tablet, and you can see where all the construction projects are in the world going on at this one time. Okay, and all of these projects are being monitored and recorded, and they're going to be analyzed, and the data is going to be used for future building, right? So it's incredible, right? So now then these automatic machines, okay, are going to start building things automatically based on the needs of the environment, right? They're also going to plan and build things based on availability of materials, like person power, people power, whatever you want to say. You know what I mean? It's gonna do like plan and design these buildings based on so many factors. It's incredible. Designers and architects and engineers are going to have so much data, right? But the need for like the junior staff isn't going to be as great, right? So there's everything that we know about the construction industry today is going to shift. It's going to change. People are going to have different jobs going into the future, right? It's going to be crazy. So one of the things that I came across is what's called optoelectronics. Okay, and optoelectronics is it's neat because it's going to be huge, right? Let me see. Actually, if I jump over to actually this isn't there's a wiki page right here. It'll give you a definition. So optoelectronics or optronics is the study and application of electronic devices and systems that source, detect, and control light, usually considered a subfield of photonics. In this context, light often includes invisible forms of radiation such as gamma rays, X-rays, ultraviolet, and infrared, in addition to visible light. Optoelectronic devices are electrical to optical or optical to electrical transducers, or instruments that use such devices in their operation. Electro-optics is often erroneously used as a synonym, but is a wider branch of physics that concerns all interactions between light and electric fields, whether or not they form part of an electronic device. Okay, so what that is our sensors, like the cameras, right? The sensors, the cameras, all those things that use light to transfer data. Okay, so data is also a form of it's electricity, right? So the data that the way we're looking at things, these devices are rapidly improving, and their optoelectronics is what we're going to be using to analyze and things like that, right? Like they're going to be like LiDAR imaging, for example, on the drones, right? Drones are going to be huge. Like we're going to getting your drone license right now. It would be a good idea. Like drones are going to be huge, and I think this year they're going to be like just coming out like rapidly, right? It's going to be incredible. Oh yeah, I saw the pasta. That looked so awesome. That's so nice, Sydney. And Aubrey's making dessert. That's awesome. That's awesome. I love homemade pasta. That's really, really cool. Yeah. My special pasta. Yeah, what makes it special? Yeah, that's awesome. Yeah, at least you guys thought ahead. I didn't exactly think ahead. I'm winging it. Right? Oh man. So yeah, look at this. So we have photodiodes, phototransistors, photomultipliers, optoisolators, right? Optoisolators, integrated optical circuit. Yeah, so they use this in security and all kinds of stuff. Let me see here. Yeah, you can kind of see here, right? This is optical sensor drone fly into danger. They get out of here. Oh, really? They want me to register to view the content? That's lame. So we won't be doing that. This photograph is very, very tiny, but you can see the picture. How the colors, right? Green and blue and all that. Those are optoelectronic devices, right? That, LiDAR imaging, for example. There's Look at this. Researchers 3D print portable microscope. Epic advocates for photonics funding. Yeah, stargazing, looking into the stars, things like that. I want chickens. That's awesome. I gotta remember to close these down. Like, look at the bug detectors, near field receivers, power counter, wireless camera detectors, video sweeper. Oh, opto kits. Look at that, a video sweeper. So it's a wireless camera detector, right? That's great, crazy. So the Optoelectronics Inc. Video Sweeper is a fast scanning receiver that detects wireless video cameras from 900 megahertz to 6 gigahertz. Malfunction here. Just the way that we see things is what this is about. We're going to be seeing things in greater detail because we can then have what's called the augmented reality, right? We can then predict how things are going to react, and that's just awesome, right? So fiber optics, right? That's another thing. Integrated optical mechanical. I'm sorry. Go back here. Yeah, electro-optics for security. Look at this. Spinel IR sensors for wide area surveillance. Yeah, kiln scanners and cameras. Let's check out that. Right, so thermography for industry. So, look at the. Right now, for up till now, we can do thermal imaging and we've scanned things for insulation, correct, to make sure the insulation's correct and everything like that. Inside walls is correct, right? We're going to be doing it real time now, right? With drones and all that, but sensors will be set up probably in sites and things like that. With external pyrometric camera, thermal mapping for the control of waste incineration process. Right? Getting attacked by a rooster? Oh god. I should have more than that now because we've got a handful of babies. Oh, you have 9 chickens. There you go. I got you. Roosters are mean, hey? That's funny. So yeah. So as we build things, we're gonna be building them with more sensors inside of them as well, right? And cameras and things like that. You can see, you're just seeing things in a different way. Look, there's a crack or something. You could maybe even predict these sorts of things, right? So, hey, sweetheart, how are you? Yeah? You're a bum. So, yeah, then for safety, in an oil rig, for example, or a refinery, the better you can monitor things there's some dangerous stuff, in a refinery, and man, refineries are dangerous places to be, especially with oh my gosh, H2O, H2S gas and things like that, right? That's just crazy stuff. Can kill you in instantly almost, right? As soon as you breathe it in. Someone's being a little butthead. And let me lose my train of thought. Let's see here. Engineering, design, and analysis. Electro-optics, right on, here we go. So electric optic systems are pushing the boundaries of technologies in industries such as research, instrumentation, metal cutting, and welding. There we go, thanks for that. I lost my train of thought. So optoelectronics, that's right. So used for things like metal cutting and engraving and things like that, right? So this is for when we start becoming more automated and construction and the factories will literally start appearing like on sites, and probably the buildings are going to build themselves, right? Optoelectronics is what it's just amazing. Like, look at see the light being transferred. You know, ever get attacked by a duck? But yeah, so they're gonna map these things, like, just incredible, right? The precision is insane, right? Like, so lasers, things like lasers, laser engraving, all that is electro-optics, right? So aerospace, research, communication. Insane, though. There we go. So materials, right? There's a new material called germanium that I've never heard of, right? So germanium is let's see here. Germanium. So germanium is a chemical element with symbol Ge and atomic number 32. It is a lustrous, hard, brittle, grayish-white metalloid in the carbon group, chemically similar to its group neighbors silicon and tin. Pure germanium is a semiconductor with an appearance similar to elemental silicon. Like silicon, germanium naturally reacts and forms complexes with oxygen in nature. So because it seldom appears in high concentration, germanium was discovered comparatively late in the history of chemistry. Germanium ranks near 50th in relative abundance of the elements in the Earth's crust. So it was, it's found a long time ago. Right? So the germanium is a conductor, and like the way they use it, you can see here. Look at this, right? Solder and all that. But Warrior Sister of Justice, good morning, happy Mother's Day. Glad to thank you for hitting the like. Yeah, hit that thumbs up. You betcha. Thank you so much. Warrior Sister is another creator. If you'd like to check out her channel, go please. Yeah, get on over there, see what you think, and you bet. Warrior's just another creator, so get on over there, check out her channel. Always cool to have new friends. But man, I was up way too late last night again, and I was like, I should have just. I'm gonna have to start scheduling the streams right for 9 instead of 8:30, because I'm just I've been having to stay up later at night to get everything ready, and it's been crazy, right? Right, look at this. So our infrared optics for thermal imaging provide innovative optical solutions in a variety of applications such as automotive, night vision, thermography, and security and surveillance, firefighting, and many others. We produce chalcogenide glass called Geyser, right? So the glass is the germanium, you know what I mean? It's what is used for the lenses, and it's amazing how the different materials react with light and give us a different view at things, right? This is the point of this, is the detail of inspections that were, you bet, Warrior Sister, and Christina, no worries, I gotta call my mom right after, but mom's always working on Mother's Day, believe it or not, so she'll be really busy today. I won't be able to talk to her till tonight. I don't know if you guys can hear the music very well, but there is music playing. thermograph free. Yeah. Right. Yeah. So it's a level of detail, right, and a level of it, like that. Right now, it's like really rough, right? Construction's rough. We go in and we're big. We got manpower, people power. Sorry, tools and things. It's really rough and rigid. You know what I mean? There's no real finesse in it, and the machines are going to make things smoother. It's the way we do things now is highly inefficient. That's for sure. But yeah, like of course everyone wants it to be more and to improve productivity and efficiency, right? And quality and strength and things like that, right? So how do you do that, right? With deeper and more thorough inspection, right? The fact that like everything will be connected, right? It's just incredible. Think about that, right? Like the whole world connected, every construction project going on in the world. Oh yeah, that reminds me. I want to try something. I don't know. Let's see here. Let's just actually go over here. I wanted to try something here. Here we go. Go to this link here, guys, and go to that link there. It won't take you away from the thing, but go to there and it'll allow you to put a message in, but it'll play like an ad off to the side, and I gotta figure it out, but I don't want it to overtake the stream because I know I saw Timey trying to use it out in her live stream the other day. But yeah, if you go to there, it'll play an ad on the side or somewhere here. I think I just picked it so it'll play a little one here. But yeah, check that out, and it'll put your message up on screen. I don't know how often that works, but it's just like another way to monetize the stream and interact as well. But yeah, actually we're at 937 subscribers, which is awesome. We're coming around to 950 and then that final 50 stretch, right? So that's been awesome. Tremendous growth lately, right? So yeah, anyways, so optoelectronics, germanium, like this kind of relates to the like transparent aluminum, right? Like it's crazy, the strength, right? The thing is with transparent aluminum and stronger materials, right? We can build, like I see, underwater. I have a feeling that we're going to be building underwater a lot more, right, than we have in the past. There's a lot of water, of course, on this planet. So the fact that we build only on land is kind of crazy, right? So I think we're going to see a lot of more things being built for underwater. Yes, congratulations, Christina. 2,500. That's so awesome. Like, it's been it's crazy. It's awesome to see everybody growing, and it's it's nice to see it. It feels good to have growth, right? To see your channel growing, right? So congratulations to you, Christina. 2,500 last week. Did I see that? I must have, maybe I missed that in the Discord or something. I hope I commented, but that's awesome, guys. That's awesome, Christina. Sorry, guys. Wowzers. I kind of suck today. I kind of out of it today. Very crazy. Actually, we're gonna go over. I got a couple other videos we can watch in the background where we can talk. Yeah, right. That's why
Proof foundations and glass curtain walls.
I love these robot voices here.
For construction technology, will there come a day
That's
when
too
noisy
funny.
construction crews are replaced by swarms of autonomous
Hey,
nanobots?
jeez, how's it going,
Will the
man?
cracks in concrete foundations one day miraculously heal themselves, or gas stations be replaced by electric
Chase
cars
today?
running on self-charging roads? Keep watching for our full list of 10 of the most exciting construction
Right, so
innovations of the
self-charging
near future.
roads, and like, did you guys, like, if you may I don't know if you noticed the one section there was talking about sidewalks, right? So the how sidewalks can absorb kinetic energy, right? And that's amazing, right? There's a renewable energy source, right? Think about how much energy the sidewalks of New York would generate. You know what I mean? So self-charging roadways and sidewalks that absorb power. The buildings themselves will absorb power. So the materials that robot voices describing that Chinese thing that you guys were talking about modified babies is disgusting. I think that's a failure of humanity right there.
Like healing agent that hardens to fill the void.
But
this is not
this
the
is
only
neat.
method of
We've seen this.
self-healing concrete. Other researchers have used bacteria or embedded glass capillaries or polymer microcapsules to achieve similar results. However, the Rhode Island researchers believe their method is the most cost-effective, prolonging the life.
Yeah, so it's just it's another form of the self-healing concrete, right? So what happens when the concrete cracks, and if water gets in there, the water will react with these are nanoparticles that will expand, right, and fill in the cracks. So that's what that is. Self-healing carbon nanotubes, right?
Is 100,000 nanometers. Your fingernail grows approximately 1 nanometer every second. Even a strand of your DNA is 2.5 nanometers wide. To construct materials at the nanoscale would seem impossible, but using cutting-edge techniques like electron beam lithography, scientists and engineers have successfully created tubes of carbon with walls that are only 1 nanometer thick. When a larger particle is divided into increasingly
So thinking about that for a second, okay? They've made particles that, like a nanometer or whatever. Your fingernail grows a nanometer a second. So think of how tiny that is, okay? So now they've made these tubes that are a nanometer like big. It's insane, okay? It's insane.
smaller parts, the proportion of its surface area to its mass increases. These carbon nanotubes have the highest strength-to-weight ratio of any material on Earth and can be stretched 1,000,000 times longer than their thickness. Carbon nanotubes are so light and strong that they can be embedded into other building materials like metals, concrete, wood and glass to add density and tensile strength. Engineers are even experimenting with nanoscale sensors that can monitor stresses inside building materials and identify potential fractures or cracks before they occur.
You see that? Like they're building nano sensors, we'll call them, that you can embed inside of materials that could predict cracks and failures. Okay, if that data could be transmitted, that is insane. Okay, so now we're monitoring the materials themselves, right?
Transparent aluminum. For decades, chemical engineers have dreamed of a material that combines the strength and durability of metal with the crystal clear purity of glass. Such a clear metal could be used to construct towering glass-walled skyscrapers that require less internal support. Secure military buildings could install thin transparent metal windows impervious to the highest caliber artillery fire. And think of the monstrous aquarium you could build with this stuff. Back in the 1980s, scientists began experimenting with a novel type of ceramic made from a powdery mix of aluminum, oxygen and nitrogen. A ceramic is any hard, usually crystalline.
I love the robot voice, right? This is awesome, right? This is what they were used for the Starship Enterprise, for the windows and that, right? But this is the stuff that will help us build underwater and higher buildings, right, with less structural steel in them and stuff like that, right? It's incredible. But yeah, transparent aluminum. Has anyone used that on any of their sites?
Permeable concrete. During a heavy storm, sheets of rainwater pour down on roadways, sidewalks and parking lots, scouring up surface debris and pollutants and washing potentially toxic chemicals like gasoline directly into sewers and streams. The U.S. Environmental Protection Agency identifies stormwater runoff in paved urban areas as a major source of water pollution. Nature has its own way of filtering out toxins from rainwater. Soil is a magnificent filter for metals and other inorganic materials. As rainwater passes down through soil levels, microorganisms and plant roots absorb excess chemicals. Knowing this, engineers have created a new type of permeable concrete that allows rainwater to pass right through pavement and let nature do its work. Permeable or pervious concrete is made with larger grains of rock and sand, leaving between 15 and 35% of open space in the pavement. Slabs of permeable concrete are laid atop gravel or another porous base material that lets rainwater settle to the soil substrate beneath. Permeable concrete is an excellent replacement for asphalt in parking lots. Not only does it significantly decrease runoff.
That's awesome. So this stuff lets water drain right through it, so that it can absorb into the soil and do naturally help itself. Aerogels are awesome too. Aerogel insulation, right? But the permeable concrete, that's great. So stormwater, like runoff and all that, is a huge pollutant, right? So when the rain comes and it just washes everything down to the sewers, right? But now this permeable concrete will let the water just absorb right through it, and which is awesome.
Which is 90 to 99% air. Aerogel is almost weightless,
Aerogel
but can be spun out into thin sheets of aerogel fabric.
Very strong.
In construction projects, aerogel fabric demonstrates super insulating properties. Its porous structure makes it difficult for heat to pass through. In tests, aerogel fabric had 2 to 4 times the insulating power of traditional fiberglass or foam insulation. Once the price comes down, it could be widely used in construction. Temperature reactive tiles. If you were alive in 1991 and lived above ground, odds are good that you owned a hypercolor t-shirt. By some scientific miracle, a miracle called thermochromic dye, the folks at Hypercolor made t-shirts that changed color with your body temperature. The commercials made it look super cool, but in reality the hottest parts of your body are usually your armpits. Glowing armpits are not super cool right today. A company called Moving Color Manufacturers.
That's crazy. So we've seen this too, right? The glass, but I wanted to talk about the aerogels for a second, because the fact that they're really good, it's a good insulation, and you could install it like it would be easier to print it than bat or rigid or anything like that, right? So the fact that we're thinking about going towards 3D printing buildings, the aerogel would be the insulation in that, right? Come on, man. Damn thing. Decorative glass, yeah. Like the way materials are going to be smarter, right?
Glass decorative tiles coated with thermochromic paint that come alive with changing surface temperatures. At room temperature, the tiles are a glossy black, but when you touch the tiles, or hit them with direct light or warm water, the colors transform like the northern lights into iridescent blues, pinks and greens. The coolest application has to be the color shifting shower. The good news for moving color is that houses don't have armpits.
Yeah, it is possible, Chase. I'll talk to you about that in a second.
Robot swarm construction. One of nature's most ingenious builders is the humble termite. With a brain the size of a grain of sand, it works alongside hundreds of thousands of mound-mates to build colossal and complex mud structures. Termites captured the attention of Harvard robotics researchers because the insects don't take orders from some central termite architect. Each termite works alone according to genetically programmed rules of behavior. Together, as a swarm of single-minded individuals, they create monumental works of mud. Inspired by termites, Researchers at Harvard's Self-Organizing Systems Research Group have built small construction robotics programmed to work together as a swarm. The four-wheeled robots can build brick-like walls by lifting each brick, climbing the wall and laying the brick in an open spot. They have sensors to detect the presence of other robots and rules for getting out of each other's way. Like termites, no one is controlling them, but they are programmed to collectively build a specific design. Imagine the applications: swarming robots building levee walls along.
Right, swarming robots. Okay, so this is crazy, man. Could you imagine, like, so swarming robots that can gather particles out of the air and 3D print materials and build things like, you know, could you imagine just all of a sudden seeing a building appear out of nowhere, like, right? You just imagine no construction equipment, no cranes, no nothing. You don't see even people. You're just like, oh, like it's like a site, obviously zoned out, but it just starts building itself, right? Like there's, you know what I mean? Like, what the heck? That's you know, that's our future, right? That's futuristic sci-fi kind of stuff. That, you know, that's probably a long ways away, but I could see that happening. Okay, like that's incredible, right? So and not only does it appear in front of you, out of nowhere, it was planned automatically, right? So like I was saying, to picture the globe, right, and all the construction projects and all the people, everything's monitored and analyzed. And so the system says, oh, we need this building here or there for this reason, that reason, and all of a sudden just pop up comes the buildings out of nowhere, right? Like that's crazy, right? Like old buildings, it's time to demo them, get rid of the old buildings. Everything's done automatically and crazy, right? Just thinking about that. That's insane. So now the world itself becomes a part of the machine, right? It's insane. It's crazy to think about. Chase, too, about the spray insulation. Yeah, you can spray insulation yourself, I think. I'm not sure. Actually, I'm not sure if you can or not. Like, usually the guys have, like, they have special trucks because there's the machines, and you need two people, one feeding the machine and one on the blower, right? So it's not something you would normally do yourself, but you don't really need to do spray insulation in your garage. I would just go with bat. And yeah, like I'm gonna be doing my garage as well here. Like I was saying, the weather's finally good now, and so hopefully we'll get started on that. I'm just gonna be using bad insulation. But yeah, the first thing I need to do is pour concrete. So we're gonna form up I gotta go around and cut around the exterior, get the siding off, and cut the plywood out. And then I'm gonna put like gray beams all the way around so that the water doesn't get in anymore. I don't know why. I can't believe they would build anything on slab like that. And every single house in this whole neighborhood and area is done that way. It's insane. No, not really. I mean, bat insulation isn't like all you do is wear gloves, and you can wear a respirator if you want. I would recommend it, but it's not like you get it's not like it gets super itchy unless you're rolling in it. You know what I mean? Like it doesn't get you that itchy. And I can definitely give you some tips and pointers on that. When you get to that point, you let me know, and I'll gladly I'll give you some pointers on that. It's crazy, man.
Dangerously flooded coastline. Thousands of tiny robots constructing a space station on Mars, or deep underwater gas pipelines being assembled by swimming swarms of bots. A similar experiment used a swarm of autonomous flying robots to build an artfully undulating brick tower.
Wow. So sorry, I keep stopping the video. But underground as well. So they're swarming robots that are building piping and everything underground, okay, or in the water swimming, right? Like doing. It's incredible. It's incredible.
3D printed houses. 3D printing has finally gone mainstream. MakerBot is selling nifty, and just about affordable, desktop machines that can print out fully rendered 3D plastic toys, jewelry, machine parts and artificial limbs. But what if you want to print something bigger than a shoebox? Could you actually build a 3D printer large enough to print out a plastic house? The answer is yes. A Dutch architecture firm has launched an ambitious public art project to build a 3D printed house. But first, they had to build one of the world's largest 3D printers, called the Camera Maker or Room Maker. Using the same plastic source material as small-scale 3D printers, the Camera Maker can print out large Lego-like plastic components that will be assembled into individual rooms of the house. The rooms will then lock together, again, think Lego, with the printed exteriors of the home designed to look like a traditional Dutch canal house. Meanwhile, a Chinese construction company is building houses using a giant 3D printer that sprays layers of cement and construction waste to assemble the homes. The company says the houses will cost less than $5,000 each, and it can produce up to 10 of them in a day. Smart roads. Google is hogging all of the limelight with its self-driving car. But what good are smart cars if they still have to drive on dumb roads? One of the most exciting new ideas is a roadway that acts as a charger for electric vehicles. A New Zealand company has already built a large power pad that can wirelessly charge a parked electric car. The next step is to embed the wireless charging technology into actual road surfacing so electric vehicles can recharge on the move. No more refueling stations. Other intriguing ideas that may come true one day include road surfaces.
So thinking about that, okay? The gas station is going to be gone. I cannot wait until gas and oil is no longer such a valuable resource. I can't wait. I don't know if I would use screws. I just don't know. That would just take so long. You know what I mean? It would just take so long to do it with screws and strength. I'm not sure. I mean, I don't know. I can't answer that question. I just know like that. Yeah, nails. Even hammering them in is quicker than drilling. So, like even by hand is quicker, man. Than screwing it, right? So, like I've done it both by hands and pneumatic and whatever, right? Like it's great, you know. And it's not that big of a job, so I would just hammer them in with my hand by hand, man. Yeah, no, yeah. This is this is neat, right? So you got solar power, and so the asphalt itself, or the whatever material now they'll be using for roadways and sidewalks, like will all be absorbing energy. Okay, so the self charging and vehicles and or equipment is going to be huge, right? So even the construction materials or the robots or whatever they decide to use, eventually will be self-charging as well. Okay, so the materials that we use now for our roadways and walkways, that itself is going to change. Everything is going to change. The only one thing that's going to remain similar is, let me see if I can jump to it right here. And we've talked about this before, okay?
They're building wooden skyscrapers and transforming high-rises into living gardens. And these designs could go a long way in improving how we live in the future.
Yeah, you're welcome, Chase.
Skyscrapers are symbols of modern ambition. They're enormous, powerful structures that offer the 1-2 punch of space and bragging rights. But the race to be the tallest is fueled by steel and concrete, two materials that account for an estimated 16% of global fossil fuel consumption. Two countries in particular, Singapore and Canada, are attempting to transform the urban skyline.
Singapore and Canada.
In Singapore, engineering firms like Woha are coating their buildings with lush native plants.
To deal with high densities in cities, particularly Singapore, where we are land limited, it is actually important to bring landscape, greenery, and nature very close to where people live and interact. It
That's
is
beautiful.
how we connect people back with nature.
Aside from the aesthetics of this building, these towers of green are also helping to bring biodiversity back to our urban centers. Because this building has vertical gardens integrated into its design, it actually contains 1,000% more plant life than could have existed on the original plot of land.
That's amazing.
And having buildings that integrate nature in this way within our dense cities could have a measurable impact on quality of life and the quality of the environment. Some of us may have experienced New York in the summertime. One of the reasons why we get a heat buildup in cities like this is a process known as insulation. When the sun hits a concrete skyscraper, heat is stored within the building and then re-radiated back into the environment, causing the air temperature to rise. However, when Woha designed the Oasia Hotel, they used plants to combat this problem.
So in our projects, we have always tried to aim for more than 100% green replacement. We need to find plants that can handle not just the wind, but also need to be quite hardy.
Yeah, wood
In a tropical
skyscrapers.
high-rise building, skyscraper, when you elevate
Wood is strong, okay? Cross-laminated timber, right? So we're using wood in different ways. It is so strong, it's stronger than steel, right? So what happens when it's hit by lightning? It's the same thing. Like, it's going to absorb it more than steel, right? The steel will light up. Steel, like the metal's a conductor, right? Wood, not so much. But cross-laminated timber is so strong.
Material because it requires much less resources to be extracted from the forest. It requires less resources to transport on site. It's faster, or it allows for faster construction.
To build a wooden skyscraper, engineers use mass timber, which is designed to handle loads similar to concrete and steel.
And I know we did a stream specially on this as well, right? The CLT, the cross-laminated timber. Like we've done a stream strictly on this. It is insanely strong and fireproof. Okay, it self extinguishes, right? So you'd think that it would be worse for fire, but it's not. It's better. It extinguishes itself. Okay, things like that will not happen with cross-laminated timber. You see the guy who puts the blowtorch on the cross-laminated timber beams, okay, and sits it there. It doesn't ignite. It just like chars, right? It just turns into charcoal, right? It just chars. That's it. It does not light up. It's insane. It's so tightly compact that the air moisture is out, right? Like, it's insane. It is so strong.
Benefits too.
In Canada, the US, Europe, the amount of wood growing is significantly larger than the amount of wood that is actually harvested. If we harvest our trees and put
Trees
them
are
in
renewable.
structures, we actually give an incentive to reforest more areas and regrow more trees.
This trend has spread to countries like the UK and Japan, kickstarting the next race for the tallest wooden skyscraper.
No, Aaron, that's
By
a great
2050,
question.
There will be nearly 10 billion
It's a
people
very
living
good question.
on this planet, and 2/3 of us
And
will be
everybody
cities.
wonders that. Everybody
To
asks
handle the
that.
rise of human population and global temperature, native plant designs and wooden skyscrapers could go a long way in curbing environmental and economic impacts. And they'll make us feel better too.
Yep. Super cool.
For more science documentaries, check out this one right here.
So cool, right? Like, I don't know if there's anything more on this video here. But
that absorb sunlight to generate
This robot voice
electricity,
guy.
or even cooler, embedding the
the neat thing is, trees are so the amount of trees that are harvested are nowhere near the amount that are being replanted and growing, right? So when they cut down trees, they have to like plant. Like, when you for every one tree you cut down, you got to plant 2 or 3, right? So look at this. What's this about? Sorry, I gotta. I'm gonna just check this out. I think I missed this one last night.
Is the single largest source of man-made greenhouse gas.
So
Every
CO2,
year,
yeah.
we pump more than 30 billion metric tons of CO2 into the atmosphere,
Wow.
where it speeds the damaging effects of global warming, while the energy sector experiments with trapping or sequestering CO2 emissions underground. A team of researchers at Massachusetts Institute of Technology
There's
has
Amos.
successfully used genetically modified yeast to convert CO2 gas into solid, carbon-based building materials. Like the Harvard termite team, the MIT researchers were also inspired by nature. This time the abalone, like other crustaceans, abalone can convert ocean-borne CO2 and minerals into calcium carbonate to build their rock-hard shells. The researchers isolated the enzyme that abalone used to mineralize the CO2 and engineered a batch of yeast to produce it. A beaker full of genetically modified yeast can produce 1 kilogram of solid carbonate from only 0.5 kilograms of CO2. Imagine how many carbon bricks they could make with 30 billion metric
Right?
tons of CO2.
Isn't that insane? So CO2, right, is what we pump 30 billion tons of it into the atmosphere every year, and it speeds up global warming. It's bad, right? So love is love, you bet, man. Shout out Team Smoke. Ant's in the house, everybody. Gotta do my thing right here. Oh, I gotta always forget here. Boom, there we go. Team Smoke, yeah. So carbon, right? So the thing is, like, now there's the materials, building materials and things like that are going to start absorbing the CO2 and other pollutants, right? Which is good. Wood is awesome, you know what I mean? And it's just like for biophilic purposes and things like that, wood is amazing, right? So now that's a thing. Okay, so we have all this carbon in the atmosphere, and with 3D printing, this is what I'm talking about. That these robots or whatever will trap the carbon dioxide and produce carbon bricks with it. You know what I mean? So, like, I'm not kidding. When they'll trap particles from the air and make the materials, the building materials on site as they're building it. That's not a fantasy. That's a reality, right? It's incredible. Hit that like, y'all, and Team Smoke. Yes, sir. Thank you so much, man. Love that. Yeah, man. Oh, dude. Yeah, I got this. Where is it now? I'm gonna show you it. So my bags, like, always come in these funky bags. I don't know if you've seen them, but there's the Sweet Island. Oh, skunk. Oh, I said Kush, but it's the Sweet Island skunk. Yeah, Sweet Island skunk. And then the Jaeger. Oh, baby, the Jaeger, and then the Blood Orange Kush. But yeah, if I like show you, this bud is crazy. Oh yes, sir. There you go. There's a nug. That's the Blood Orange Kush. So good. And then it's too bad there's not a big buds left of these two. The Jaeger's always so good too. Oh yeah, bro. Let's pull out. This is the Sweet Island skunk. It's a smaller nug because I've been pulling off of it, but. Oh yeah. Oh, so yummy. Ooh, that in this the Sweet Island skunk, it smells cheesy, right? So when I find when it's a sativa too, right? I've been actually starting to smoke sativa in the mornings, and indicas more later on, and it's actually been really good. I'm enjoying it, which is unusual, I guess, because when I'm working in construction, it's indica all day, right? But when I'm not, I don't need the painkiller as much, right? So I love it, right? Oh yeah, it's so good. Like I was saying, the people that I use, like, I call them up, and there's a delivery guy at my door, like within an hour, right? So it's awesome. You know what I mean? I just call them up, and the delivery guy's here within the hour. with a menu. Hey, which one do you want? There's all kinds of products, right? There's Shatter. They got capsules now. They got all kinds of stuff, right? So it's crazy. So good. Very handy. What do we got?
Sturdier, futuristic alternative to plexiglass. Transparent aluminum. This stuff is supposed to be so strong that it makes up the viewports of the Enterprise. The coolest part, though, is that this stuff is not just science fiction. Transparent aluminum actually exists, and it pretty much lives up to Scotty's hype. And it's just one of many cool new materials that seem like they were plucked straight out of science fiction. From invisibility cloaks to self-repairing concrete, the future is now.
Yeah, the transparent aluminum's awesome. Aerogels.
Gels are mostly liquid, but they act like solids because there's a bunch of molecules in them that link together and hold the liquid in place. Aerogels are gels where the liquid has been replaced with gas. Imagine taking your favorite gelatin dessert and sucking out all the water, but instead of crumbling into a powder, it still keeps its dome-like shape. That's basically how scientists create aerogels. First, they make a gel out of something like silicon or carbon compounds. Then they use extremely high temperatures and pressures to blur the line between the liquid and gas phases, creating a supercritical fluid. Then the kind of liquid, kind of gas can drift out of the solid molecular structure and be replaced by air, so you have a porous, lightweight material that retains its shape. Aerogels are great for insulation because the air inside doesn't transfer heat very well, so they're mostly being used in spacesuit and spacecraft linings. Plus, they're almost transparent, which means we could use aerogels to insulate windows here on Earth. When they get cheaper.
Hold on. Okay, this is important, guys. This is important. Let me know, have you been hearing an echo on anything? Has there ever been an echo at all on this video? Like, does the audio sound echoey at all? And then 2, can you still hear the video?
Harry Potter fan, chances are you've wanted your own invisibility cloak. But instead of using magic
Can you still hear the video? Let me know.
Muggle researchers need to experiment with light. We don't have large-scale invisibility cloak technology yet, but scientists are working on a lot of different ideas, like creating flexible sheets of liquid metal that can block radio waves used in radar. And we're getting closer. In 2015, scientists designed a very, very thin material, like 80 nanometers thin, that could hide equally tiny objects. In order for us to see an object, light has to bounce off of it, and any distortions of that light reveal its shape and features. This invisibility cloak uses teeny tiny brick-shaped gold antennas to counteract that natural light distortion. So when this cloak is wrapped around an object, any light bouncing off of it looks like it's coming from a perfectly
so you can
flat
hear the
mirror,
video still?
hiding
That's
the fact
amazing.
That the cloak and object are even there. And
that is amazing.
you can adjust the gold antennas to make the reflected light look like any object
I can
in the
now
background.
control the audio from everything with the dials on my mixer.
Okay,
like I had the audio going on the
invisible. So we can't
on the
quite make
Streamlabs, right? I had audio there,
what about super
and had default capture as well as my mic input. So now all the audio is coming from the mixer into the microphone input. So that's incredible. So now I can change the quality of the audio that we're listening to as well on my stereo channel. Is what I'm using, right? Which is awesome. Wow, I love the mixer. Neil, thank you for sending me this mixer. I
Another
love
idea
it.
is to make surfaces that are covered in itty-bitty ridges or polymer cones that are just tens of nanometers in size.
Dudes, there's camouflage, right? Like the materials that reflect light, or that don't reflect light, they absorb it, right? Is like chameleon-like properties, right? Giving that to things, it's incredible.
Growing on ships. Carbon is amazing, like the basis of all life as we know it, amazing. We've talked before about how awesome some carbon-based materials are, like graphene.
Wow.
But we can use what we know about carbon to make a material even harder than diamonds. Aggregated diamond nanorods, or hyperdiamonds if you want to sound cool. These are the hardest, most dense, and least compressible material we know of. Diamonds are hard because of their molecular structure. Each carbon atom forms 4 covalent bonds with the atoms around it, which forms an exceptionally hard crystal structure. In hyperdiamonds, that's still true, but it's a different, more wear-resistant form of diamond. This material is made up of many tiny interlocked diamond crystals rather than one single structure. They can be made in the lab by applying extreme heat and pressure to graphite.
Thanks for
Diamonds are
letting me
frequently
know,
used for industrial jobs like grinding and polishing because they're so tough. But hyperdiamonds can be even more useful than regular diamonds because they're even more resistant to the temperature and pressure changes that can wear diamonds down over time.
Thank you, guys.
Now, when can metal also be glass? Well, when engineers invent metallic glass, also known as amorphous metal. Most metals have a crystalline structure. The atoms are ordered into a specific repeated pattern that makes it stiff. But glass has a random arrangement of atoms, which makes it more brittle. So metallic glasses form when metal atoms are in this random arrangement, like when melted metal is cooled really, really quickly before its particles can arrange themselves into a crystal. This material has the best of both worlds, the malleability of molten glass combined with even more strength than crystalline metal. This combination of high strength and low stiffness makes it really resilient. It can store and release elastic energy better than other forms of metal, which means it doesn't deform as easily. Right now, metallic glasses are being used as coatings to make objects more corrosion or wear resistant, or to make products like golf club heads. But eventually, the material could be used to easily manufacture things where strength and weight are concerns, like lighter, stronger car parts. But glass isn't the only hot new metal material. Metallic foams are made up of a metal like aluminum and a whole bunch of gas-filled pores. This makes them super light, plus they keep many of the original properties of their metal, like being strong, fire-resistant, and conducting electricity. Metallic foams can be made a few different ways, like by injecting gas into a liquid metal or by causing the precipitation of gas that's already dissolved in a metal mixture. And some are open-pored, meaning that the gas pores inside are all interconnected, creating what are sometimes called metal sponges. But in closed-pored metal foams, the little bubbles are all separated, which means they can float in water, which could be helpful for building sturdier, lighter boats and spacecraft that can make water landings. In general, metal foams are useful for high-tech shock and impact absorbers. The gas inside makes them extremely compressible, so they can absorb a lot of mechanical energy while still retaining some of the strength and durability of a metal. This means they also have a lot of potential for building different car components that are light and sturdy. Some metals also have unique new uses, like aluminum. In Star Trek IV, it's called transparent aluminum, but that's kind of inaccurate. The material our scientists are manufacturing is really aluminum oxynitride. It's composed of aluminum, oxygen, and nitrogen. It's a ceramic, which means the material starts as a powder and is then heated up until it melts, then cooled into a crystalline structure similar to glass. It's basically transparent and extremely strong, nearly as hard as sapphire, so aluminum oxynitride is really useful for things ranging from bulletproof windows to super durable camera lenses. It's still expensive to make, but hopefully we'll find ways to make it more efficient by the time we get around to building starships. Concrete. I'm sure you're familiar with it. Just today you've probably walked on it or sat on it. In fact, it's probably all around you right now. But as materials go, it's not
concrete, right? Like, so think about hey, Vince, man, how's it going, buddy? BCG Construction, Vince, dude, nice to see you. Very cool, man. How are you today? I wanted to kind of think about that. Go back to the metallic the metal, right? The metal foam. That's really neat, right? For using it, I can see that being used to make the machinery, right? That will would build things on the water and things like that, right? Like also a lighter and stronger. That's really cool, right? You could use that so many ways. It's just insane, right? The self-healing concrete again. It's like if everyone loves this self-healing concrete thing, right? Nanoparticles are incredible. The fact that you can stretch them way out longer than their thousand times their regular size. You can they're very strong, okay, and very, very tiny. Like I was saying, the size of one nanoparticle is your fingernail grows 1 nanometer a second. Okay, so that's how small these particles are, and when they're put into the concrete, and concrete cracks, water gets into the crack, then the nanoparticle reacts and expands and fills the cracks. So like I was saying, they're saying right now it only works on a small scale for certain like installation pieces, art pieces, and things like that. But on the bigger scale of things, like we could start to see it everywhere. Okay, like sidewalks, for example, like curbs and sidewalks, and everywhere we use concrete. So not thinking about that, right? The sidewalks are self-repair, right? And this can last for thousands of years, right? It's insane. It's crazy. Oh, did the stream just get suspended? Oh man. Yeah, the self-growing bricks, like I was saying, the self-growing bricks are really cool too. That they take carbon dioxide out of the air and use the carbon to build bricks, and then they release oxygen, right? Something weird's happening right now. Huh. All right, that was weird. Sorry, one of my monitors just kind of screwed up on me there. Stream's back. Stream's unavailable still, or am I just content issues? Is the stream back? Because yeah, they're telling me I content issues. That's so stupid. Like, get on with it, right, Timey? Like, get out of here. Oh no, that's okay, Jason. That's okay. Timey can say that. Yeah, WTF, right? Like, so I'm back. So this is the thing. This has happened now 3 times to me, okay? Where my stream will stop at some point, and it's like as if somebody's reviewing it or whatever. And no, that's okay, Timey. You're allowed to say that here. We don't. They do that. Like, this is the 3rd time they've done that to me now. So I think what happens is like the might have to be like manually reviewed, you know. So like when a copyright thing comes on or whatever, they want to make sure you're using the content properly and not just like restreaming content, right? So if you're doing what I'm doing, it's okay. Okay, so we're talking about it. We're talking about the materials, and we're doing commentary and things like that. So that's allowed. All right. So you're not allowed to just replay content. Okay, so that's happened 3 times now, and it's kind of freaky, right? Like, how like, I don't know, it's crazy. This copyright stuff is just so ridiculous. It blows my mind. But yay, I'm back. Yes, thank God. Yeah. I mean, I get it, I guess, but I mean, come on, guys. Like, how many? You should be able to like earn like trust points or something, you know what I mean? Like, this is probably, I've done close to 100 streams, right? So if not 100 at least, you know what I mean? I could check on Studio to see how many I've done. I'll just do that real quick. So in theory then, no, I didn't message YouTube. No, they just did it automatically, right? They like I was saying, they stop, and then it stops for like a few minutes, and then it goes back on. So, and it says content issues, right? So somebody's probably manually reviewing the stream to see that we're not, like I said, just restreaming stuff, right? But crazy, eh? So actually, here's another good question. The music is the music lower and my voice loud and clear? That's the real test now, because I have the mixer, I have the music down on the mixer, and then the mic audio should be a lot louder. So that's the real test right there. So yeah, if I go to where am I here? Oh, yeah, I was gonna go over and check out how many I've actually done, just for craps and giggles. If I go to that here, and then transfer to Studio, it'll tell you how many live streams I've done, which is cool. Yeah, I know, right, Timey? It is freaky. Like, God, they're really like, man, it's so corporate now. Like, it is so. Yeah, I must have been jealous of my skunk. That's hilarious. Now it was India putting a copyright strike on me, or copyright claim on me, right? Oh man, yeah. Ever since that whole stuff, this has only been happening since the stuff with India has been happening. Okay, like that's just started happening. So it's insane. Like, God, they just totally messing everything up. If I go, not there, but yeah, studio. Oh, bummer. Go back. And then go into studio beta. It'll tell me. Yeah, you bet, Timey. Tell Mom Happy Mother's Day. Oh, 939 subscribers. Right on, guys. Yeah, we're closing in. We'll hopefully be at 1,000 by the end of the month. Uploads and lots. So I go to live. It'll tell me. Oh my God, that's hilarious. This is our literally our 100th live stream right now. We are on our 100th live stream as we speaking right now. 100 live streams. You can message YouTube through Twitter or through the Creator Studio. You can message YouTube. That's so funny. So I didn't get any feedback on the audio. I know I'm asking a lot, guys, this stream, but like I said, I need to go back and watch the replay to make sure everything's good. So my mic audio should be loud and clear, and the music should be low, so you can hear my voice nice and clear over top of the music. Let me know if that is the case. Yeah, happy 100 stream day on Mother's Day. It's incredible. This is awesome. The YouTube has been so much fun, and all the people I've met and the things I've learned, it's just out of this world, man. I can't believe the stuff, like the studio we have down here now is incredible. Like, I got even Ben's station is starting to get better. It's just awesome, right? Yeah, help ticket. That's right. Yeah, through studio. I've never had to do that, so I it's just, yeah. The self-growing bricks is amazing, right? Yeah. Virtually alien components, right? That's what I mean. Like, that's incredible. Yay, stream 100. That's awesome. So yeah, I've got up. So I got over 100 videos, and then this is the 100th stream. So I got like 120 videos, and now 100 live streams. So it's pretty crazy. Yeah, like windows and domes for undersea and deep space vehicles. That's the thing, right? Like we don't explore underwater like as much as you think we would. Being such a water planet, like why are we not, like, we only build on land, right? Why not underwater, right? Why not have vehicles that can explore the depths of the oceans and things like that much easier, right? Think about what we could learn under the seabed itself. What could we learn, right? What could we find down there? It just blows my mind, like the possibilities, right? Oh, this stuff is really cool. Has anyone seen this before? It's called Bling Crete. I'm gonna go back to it, okay? Bling Crete, and let's see if I can get the audio up on it. I need to go get this audio up. I don't know if it. Okay, so there is no audio on it. So the Bling Crete, it infuses like glass or whatever into the concrete. So this stuff you can glass balls embedded into high-tech nano optimized concrete, right? So that you can now have signage and things like that that these are not like they light up. It's incredible, right? So it's injected or into the concrete itself, right? It's amazing. So yeah, it's an artistic way of doing it, right? Think about the chemicals and stuff in certain paints and things like that, right? This is just awesome, right? And then of course those are the pollution eating bricks, right? Materials of the future. I don't know if there's
Sky, here are 13 of the coolest materials of the future that are being used right now.
Explain. Origins is awesome. Origins Explained, guys. I'm not
Aerogel.
subscribed.
Aerogel holds 15 entries in the Guinness Book of Records for material properties, more than
Right.
any other material. It is the world's least dense solid. Sometimes called frozen smoke, aerogel is made by the supercritical drying of liquid gels of alumina, chromia, tin oxide, or carbon.
Right.
It's 99.8% empty space, which makes it look semi-transparent. Aerogel is also
It's
a
incredible.
fantastic insulator. If you had a shield of aerogel, you could easily defend yourself from a flamethrower. It stops cold and it stops heat. You could even build a warm dome on the moon. Aerogels have unbelievable surface area in their internal fractal structures. Cubes of aerogel with just an inch on one side may
That was
have an
Timey.
internal
Happy
surface
Mother's
area
Day, Timey. I'm
equivalent to a
sorry.
football field.
I'm sorry it took me so
Aerogel is
long, but
currently being
happy
used
Mother's
as an
Day, Timey.
insulation product, thickening product in cosmetics, laser targets, blankets, in spacesuits, military armor, and in particle physics, just to name a few. Fun fact, NASA uses
Right?
aerogel
Yeah.
to trap space dust particles aboard the Stardust spacecraft. The particles vaporize on impact with solids and pass through gases, but can be trapped in aerogels. And to
Right.
think that aerogel was created from a bet. Number 12,
A bet.
carbon nanotubes.
That's crazy.
Carbon nanotubes are long chains of carbon held together by the strongest bond in all chemistry, the sacred sp2 bond, even stronger than the sp3 bonds that hold diamonds together. Carbon nanotubes have numerous remarkable physical properties, including ballistic electron transport, which makes them ideal for
Ooh.
electronics, and so much tensile strength that they are the only substance that could be used to build a space elevator. Yep,
Space
just like the one
elevator.
that Google is trying to build.
Google space
Nanotubes
elevator.
could be used to build a pipe that transports materials and maybe even humans to the International Space Station or the moon. The specific strength of carbon nanotubes is 48,000 kilonewtons per kilogram. The previous record holder for structural strength was high carbon steel with a measly 154 kilonewtons per kilogram. That's 300 times
Right.
stronger than steel. You could build towers hundreds of kilometers high with it, or the world's strongest and tiniest straw. Your pick. Number 11,
Right.
metamaterials. Metamaterial refers to any material that gains its properties from structure rather than composition. Metamaterials have been used to create microwave invisibility cloaks, 2D invisibility cloaks, and materials with other unusual optical properties. Mother of pearl gets its rainbow color from metamaterials of biological origin. Some metamaterials have a negative refractive index, an optical property that may be used to create super lenses, which resolve features smaller than the wavelength of light used to image them. This technology is called sub-wavelength imaging. Metamaterials would be used in phased array optics, a technology that could render perfect holograms on a 2D display. These holograms would be so perfect that you could be standing 6 inches from the screen and not even notice it's a hologram. And now for number 10. But first, remember to
Crazy.
subscribe and let me know what you would
Little
like to see in
butthead.
future videos in the comments below. Number 10, aluminum bubble wrap. Imagine your favorite packing-based stress reliever,
Right.
except made of metal. Okay, metallic bubble wrap might not be quite as easy to pop, but it could be a heck of a lot more useful. A team of engineers from North Carolina State University have developed a new form of aluminum bubble wrap, which they claim could revolutionize packaging and protective equipment. The scientists take a thin sheet of aluminum, then use a studded roller to form small indents in the sheet. Unlike its polyethylene counterpart, these voids are then filled with a foamed material like calcium carbonate before being sealed with another flat sheet of metal. The result is a series of bubbles that absorb masses of energy, weigh 30% less than regular sheet metal, and yet are nearly 50 times stronger. It's easy to make, not too expensive, and could soon be used in everything from shipping containers for fragile goods to bike
Wow.
helmets. Just don't be
50
tempted to
times-
try and pop it. Number 9.
50 times stronger than sheet steel. That's amazing.
Want to get your hands on, and it's made out of titanium. By saturating a humble polyurethane foam with a solution of titanium powder and binding agents, it's possible to force the metal to cling to the shape of the simple foam and then vaporize the underlying structure away. The result is a titanium lattice in the shape of the original foam, which can be heat treated to tweak its material properties.
Wow.
The exact properties depend on how porous the foam is, but the results are pretty interesting. The structure is both strong and, most importantly, incredibly light.
The way that it's
in fact,
done,
the material
Jason,
is perfect for replacing human bone. It has incredibly similar mechanical properties, and because it's porous, new bone can grow in and around its structure, truly integrating the implant within the skeleton. Number 8. Molecular superglue. If you've ever stuck your fingers together with superglue, you know pain. Now imagine sticking them together with glue that bonds materials at the molecular level. That's real pain. In fact, a team of researchers from the University of Oxford has created a molecular glue inspired by Streptococcus pyogenes, the flesh-eating bacteria. They considered a single protein from the bacterium, the one it uses to bind to human cells, and from there developed a molecular glue which forms covalent bonds when it comes into contact with a partner protein. The bonds it forms are so strong that when researchers tested a sample, the equipment used to measure the strength broke before the glue did.
Right, Jason?
All that remains is to develop ways of incorporating the proteins into other molecular structures in order to create insanely strong
layering,
selective
right?
glues.
Because
Sounds like
the other
in a
way,
Marvel comic
it's
book.
like
Number
inside
7,
the air.
artificial
like,
spider
is
silk.
inside,
Silk is
but
nature's
this is
very
like
own
there's
homespun
like 2
wonder
layers
material,
with the
but
air in
it's
the
tough
middle,
to make in
right?
bulk. This is why a
That's what I
Japanese
think.
startup called Spiber has been working out how to produce it synthetically.
Right.
It's managed to decode the gene responsible for the production of fibrin in spiders,
Oh,
which
yeah,
is the
that
key
reminds me.
protein
Nobody
used
tried
to
out
create
the
super
link
strong
that I
strands of
sent
silk.
out, eh?
The company can reportedly create a new type of
know if
silk
it's
from
gonna work.
scratch to
If I
a finished
check it
product
here.
in just 10 days. The bacteria feed on sugar, salt, and other micronutrients and quickly produce the silk protein. This protein is turned into a fine powder, spun, and processed to create fibers, composites, solid block, pretty much anything. A single gram of fibrin produces 5.6 miles of silk. They're working on mass-producing the stuff to revolutionize the textile industry and are churning out silk by the metric ton. That's a lot of silk, and all of that without a spider in sight. You can already start buying jackets made from this silk. They have a heavy price tag though, about $750 a piece. Number 6. Bacillophylla. Concrete ages over time, taking on the sickly, polluted gray look we all know and developing fractures in the process.
Hopefully that
Repairs
works.
are
I think
time-consuming
that
and
was-
expensive. If the foundation of a building cracks, there's often no easy way of fixing it. Many buildings in earthquake zones have been simply torn down for this reason, but a group of students at Newcastle University have produced a genetically modified microbe that has been programmed to swim down fine cracks in concrete and produce a mixture of calcium carbonate and bacterial glue to knit the building
Okay, so
back
maybe
together.
I didn't have it set up right, but
programming
maybe
of
now
the
it'll work.
Bacillophylla spores mean they only start germinating on contact with concrete. Can
Timey,
sense when
yeah,
they
you
reach
had this
the bottom
going the
of
other day.
cracks,
I know I had
harden
installed
to
it
the
too
same
that day,
strength
but
as the surrounding concrete, and have a built-in self-destruct gene to stop them going rogue and producing massive concrete tumors.
right?
There are also environmental implications. 5% of all man-made carbon dioxide is from the production of concrete. It is hoped the
So,
spores
yeah,
will be
somebody
able to
check out that
prolong
link
the
I
life
put
of
in the
structures
chat
that would be
there
very
and
costly
see if
to
it works.
rebuild.
But
Number
I'm just
5,
interested. I don't
amorphous
want
metal.
it to go crazy or anything
Amorphous
like that. but-
metals, also called metallic glasses, consist of metal with
Yeah,
a
'cause I didn't
disordered
have it set
atomic
up.
structure.
Did it
Because
do
of
it-
their
did it
disordered
just do it
structure,
again?
They can disperse impact energy more effectively than a metal crystal, which has many weak points. Amorphous metals are made by quickly cooling molten metal before it has a chance to align itself in a crystal pattern. Amorphous metals may be the military's next generation of armor before they adopt diamondoid armor mid-century. On the green side
Right.
of things, amorphous metals have electronic properties that can improve the efficiency of power grids
Oh,
by
I
as
see. I
much
got
as
you.
40%,
I got you, Jason.
saving us thousands of tons of fossil fuel emissions. Number 4, glowy.
Glowy.
Bacteria may light up the future. Glowy, a startup company based in Paris, is developing bioluminescent lights to illuminate shop fronts and street signs.
Right.
After a successful demo in December, Glowy has launched its first product, a bacteria-powered light that glows for 3 days. The company is now working on
Wow.
lights that will glow for a month or more. The lights are made by filling small transparent cases with a gel that contains bioluminescent bacteria. Glowy uses a bacterium called Vibrio visheri, which gives marine animals, such as the Hawaiian bobtail squid, the ability to glow with a blue-green light. The gel provides nutrients that keep the bacteria alive. At first, the lights only worked for a few seconds, but by tweaking the consistency of the gel so it delivers nutrients more efficiently, the team has been able to extend their lifespan to 3 days. Bioluminescent lights are not new, but Glowy is one of the first companies to develop a commercial product which is initially being marketed to shops. In France, retailers are not allowed to light their shop windows between 1
see,
a.m.
Jason.
and
Okay,
7 a.m.
I'll figure it
to
out
limit
after.
light
Probably because I
pollution
didn't
and
set it up
energy
before the stream, but
consumption. The softly glowing bacterial lights, which are about as bright
so
as
that's
night lights,
kind of neat
provide
though,
a
right?
way
Like
to
thinking
get
about
around
the
ban.
designs. Things
Number
are going
3,
like
graphene.
Like everything
Graphene
we
is the
know
strongest
about
material known
building
to science at the
and
present time.
how we're building it,
It is
what we're
200
building
times
is
stronger
gonna
than steel,
change.
and it is one of the
Like,
strongest, thinnest, and lightest material in the
it's
world.
incredible.
Graphene is single layer of pure
Like to
carbon
have that,
arranged
like
in a
the
hexagonal
signage
lattice
inside the
pattern.
glass,
It is
right?
so
Like
thin,
that
it is
is
considered to be
amazing.
a two-dimensional object. This newly discovered material might be one of the most important known to man. It has amazing thermal and electrical conductivity properties, and it is also very malleable but at the same time very strong. This means it can be used
Graphene,
for many different things such as high-capacity batteries, flat-screen televisions, and for very small computer chips. It's made by taking special adhesive
Germanium.
tape to collect residue from graphite, the same material used in everyday pencils. This easy and simple yet groundbreaking experiment was conducted by Andrei Geim and Konstantin Novoslov. They later won the Nobel Prize for Physics because of these experiments. Graphene is definitely
You too,
going to
Aaron.
have an
You have a
impact
great
on
day.
the
Thanks for
world.
coming, my man.
Number
Nice to
2,
have seen you today,
D30.
buddy. Happy Mother's
Impact
Day.
protection has always been a difficult problem. How do you make something that offers real protection without becoming too heavy or inflexible? Plastic knee pads, for example, restrict movement and can still transmit impacts to the bone.
I can't.
D30
I don't
offers
like
an
knee
ingenious
pads. I
fix
can't
to
wear
this
them. They're so
problem.
uncomfortable.
It's a material made of intelligent molecules that move freely under gentle pressure but
D30.
lock up when struck hard. Jackets are already on the market containing D30 pads that offer flexibility as well as protection from the tarmac, baseball bats, or fists you might accidentally walk into. The
Yeah,
pads are low
sure.
profile, making the jackets suitable for stuntmen or even police. The material actually works on a familiar
construction
principle,
workers,
similar
right?
to the mixture of cornstarch and water.
Nobody
you
ever thinks
remember
about
from
construction
elementary
workers.
school science
That's why.
experiments.
That's what
Who knew your
frustrates
4th grade
me so
science
much,
fair
right?
could lead
Like
to scientific revolutions like this?
They always
Number
always
1.
talk about cops and military, but construction workers always get left out, right? We die at a higher rate than any of them. All of them combined, we die at a higher rate, right? And no, we never get that credit. We never get any credit for that.
Graphene aerogel. If the phrase graphene aerogel sounds to you like someone combined the two buzziest of materials buzzwords, then you would be right. In fact, this graphene aerogel snatched the title
Very
of the
neat.
world's lightest material just a few months ago, with a density lower than that of helium and just twice that of hydrogen at 0.16 milligrams per centimeter cubed.
Wow.
This stuff practically floats on air. The material was actually created using a new technique which involves freeze-drying solutions of carbon nanotubes and graphene to create a kind of carbon sponge. The resulting material is both strong and elastic, as well as incredibly light. It can even absorb up to 900 times its own weight in oil. When or if it becomes affordable, it could potentially be used to mop up massive oil spills with ease, or even as an incredibly efficient version of humble old insulation. The possibilities are endless. Thanks for watching. Who knew that graphene was so cool? Be sure to
Graphene,
subscribe,
right?
and I'll see you next time. Bye,
That's neat.
everyone.
So like I was saying, lighter weight materials, like the things that we're discovering are incredible, right? And a lot of it has to do with the like the mapping and sensors, right? Like it's just the fact that these tinier materials that they're like that have so many properties, right? Like the 3D print, right? It's like a liquid gel that dries or something, right? Like it's insane. The where we're getting the particles or whatever, the molecules to build it is insane. Just right out of the air. It's just like I'm saying, it's insane, right? When I heard about graphene and all the properties of it a few years ago, I thought we were already going to have these great graphene batteries, but no, right? It's like still expensive, I think, right? It's crazy. Like the industry, it withholds things like that. Yeah, it's, why they put so much into the military, right, for safety, and they put nothing into construction for safety, and like it's crazy. Like, it just makes no sense to me. But yeah, so yeah, this is actually just a neat. I'm not gonna play this video, just to give you an idea of Industry 4.0 and how it's gonna be changing. Okay, I can't wear knee pads. Yeah, me too. Exact same reason why I can't wear knee pads, Jason. That's the exact same reason why I can't. They're so frustrating. So look at this guy in a suit. Okay, think about that. Right. So you know what I mean, guiding the machines to build. So you could be anywhere in the world doing that. You know what I mean. You don't have to be on location, which is crazy to think about. Right, so data connection, right? Look at this political agenda, Germany trade investment, research and development. That's crazy. Yeah, so we could, like I'm saying, guys, it's this is where construction's going, guys. Just like everything else, right? Robots, the technology is insane. Like, it's been done the one way for so long. Like, I now that with these new materials, we can do things like this, right? We can automate, use robots and different, like 3D printers, for example, different and new equipment to do things. That right there was optoelectronics as well. Optoelectrics, like I was saying, like the detail, the smallest detail in engraving and metal cutting and things like that, right? It's just like crazy, right? Look at for inspection, right? We can go places where we couldn't before, right? And it will do it autonomously eventually. But yeah, like look at, I just want to see, there's a big floor, right? Like the factory floor or whatever. There'll be building things. If we build things on site, I'm gonna say there'll be little tiny factories, portable building factories that'll show up, right? And in like Superman days, when we're thousands of years in the future, we'll be, like I said, the buildings will just appear out of nowhere. It will seem they'll build themselves with the, like, you won't see any equipment or any machinery. It'll just appear. It's insane. It's insane. The reason why things haven't been automated is because we have trades that have to go in. You got to go in and do the framing, and like different crews do different things. But now they can combine the processes, right? If as soon as they can start printing the wires and the pipes and insulation in the walls and things like that, then they're going to be 3D printed, right? Somehow the machinery like that'll like those little tiny termite bots, you know what I mean, like just a swarm of termite bots will show up and 3D print the materials they need on site as they need them and stuff like that. It's insane. I thought this was kind of cool. This is nothing to do with today's topic, but we'll end it with like a bit of a comedy or a cool little golf right. I'm gonna put on our own music, so it's copyright free. And yeah, this is the time. Any final thoughts? Any questions? Let me know. And yeah, Mother's Day today, so we're gonna be closing her down here quite shortly. And yeah, I want to thank everyone for coming. Yeah, another good trade. I know it's a little funky. I'm like, my mind isn't here. The built-in knee pads, yeah, right. They look cool. I seen the Helly Hansen pants with the built-in knee pads. I'm thinking about getting them they're at Mark's Warehouse or whatever. Yeah, that's not a really cool invention to me. You know what I mean? Like that's something like you'd think they would have thought of a long time ago. Look at this thing. Look the Mammoet, right? Those hydraulic lifts that they have, that with the wheels, you know, like the drive under the things. That's actually pretty cool. pro sod cutter. That's hilarious. Oh yeah, look at this thing. Look at the tracks on it. Nice, yeah, narrow profile for more rows. That's actually really neat. Narrower, yeah, that's actually kind of cool. Never seen that. What's Skidometer? Look at this, construction technology 4.0. That's definitely nothing to do with construction. Oh yeah, there we go. The drone though. So we see a lot more. Oh yeah, the window washer. Yeah, right on, the window washer drone. That's hilarious. Just watching it doesn't string. Right? Exploding golf balls. That's awesome. It's just aromatic. Oh yeah. Oh yeah. So see that? It was just literally just following the operator, right? So you don't have to drive it. It'll just follow you. Look at right. First autonomous driven urban waste vacuum cleaner. Yeah, it'll follow. Just like there's luggage now that you can get that'll literally follow you down like through the airport, right? You don't need to you're not going to need to pull it behind you, right? It just automatically follows you, right? You'll have it connected to your watch or phone, and it'll just follow you right through the airport, which is incredible, right? Think about what kinds of machinery would that be beneficial for in construction? I don't know, man. Like wheelbarrows, for example, right? If you could, you know what I mean, have them autonomously, go and bring like the concrete from the truck to to a certain spot or whatever. Like that's just crazy. The thing is, like those machines aren't as like durable as we are. They don't have the agility that we do, right? Like for climbing and avoiding obstacles. Like construction sites are messy, right? You guys know that. So all right, Timey, you're back. Good stuff. I was just talking about loots, right? And how you had it set up really well on your stream the other day. So I this is my first stream that I've done since I installed the plugin, but I need to do some more configuring. It's not working yet, but I gotta just make sure that they have 1 sec. Had to make sure they're wearing clothes. Little Addie comes down here. She's just in a towel, butthead. When I installed it, when I saw the plugin show up on Streamlabs, like, I don't know, a few days ago, and it's not working right now because I didn't have it connected to my YouTube properly, but there we go. Now the audio should be a little better. So hopefully the audio is working. Yeah, we want it around there, but I just don't hear it in my earphones. But yeah, my voice should be louder. Oh yeah. But so yeah, I'll look at it again after the stream, and do I still have the link? Try it out, Timey, because you know it. So maybe you'll be able to see. Awesome, Vince. Thank you so much. Yeah, Neil sent me a mixer, his Behringer Xenix 802. So, man, I just I'm having a lot of fun with it, and it's nice to be able to control the audio from dials, physical dials in front of me now. Like I have the PC default audio routing to here first, and then into the computer, so I can now control the levels of volume right from here, which is so badass, right? Yeah, you made a little bit of money during the last stream. That's awesome. I would like to definitely try it out some more. Yes. Oh, I did, Vince. Guess which one I'm going with? I'm going with the Sony A6400. Oh, did it work? Oh, cool. We'll see if it shows up. That's awesome. So yeah, I'm going with the Sony A6400 with the lens and everything like that. It's about $1,400, so that's a lot less money than the Sony A7 III. You have questions? Yeah, Jeffrey Eatley helped me out deciding on that. He was really helpful the other one night. We were streaming kind of late night, and he popped in, and the A6400. I'm gonna get a capture card. The capture cards are about, you can get the Elgatos, I think, for a couple $100, but I'm gonna go with a different brand. It's a better quality capture card. So that's gonna run me like $500, but that's okay because I can just transfer it from computer to computer. So it's gonna look awesome. The live stream should look really awesome. I'm gonna get it mounted so we got a nicer, wider shot, and it's gonna look so good. But and then it should look really, really good. I got a couple of ideas I'm setting up for actual shooting videos as well. So I got a couple of things. I might get the DJI Osmo Pocket, right, as well for instead of using the GoPro, I'm gonna get that. It's got the oh, there's the ad right there. It did work. Great on. The Predator, yeah, the i7s are nice chips. So it's in a bad spot. Let's put it over here. There we go. Hey, guess what? I sent you a message. Right on. Thank you, Timey. Yeah, I guess I gotta kind of maybe center that properly. Oh, that's why it's like that. Okay, I see. Nice. I didn't have it centered properly either because I was looking at the other little tiny one, but I guess it kind of randomly picks the one, so that's cool. That's awesome. Thank you so much, Timey. I appreciate that. Yeah, guys, that's a kind of a way to monetize the Loots is an awesome Streamlabs plugin, and you can play a message to me, and it's supposed to pay a little bit of money for displaying ads or whatever, which is cool because they only come when the audience requests them, right? So there must be a time between them that you can use as well. I'm not sure how that works, but you know what I mean. It'll time them, which is really cool, man. Yeah, each one has a different value. That's right. The different sizes have different values. That's right. So that's really cool. It's a good way to help tip the creator, right? So you don't have to actually give money out of your own pocket, right? Which is super cool, right? I love Streamlabs. They're so innovative, and they are always looking out for the small creator. And I can't appreciate them enough for doing all the things that they do. But thanks, guys, for coming today. I gotta go. It's Mother's Day. I gotta get going. Everybody, kiss your moms. Tell them you love her, and I'll see you guys very soon. What's the next stream? Well, we have Creator Chaos Tuesday night, so not sure what the subject will be this time, but I'll be there on time. It's 6 p.m. Let's see. Blurb gave me a amazing gift, but there is an issue, and I need your help. Oh, hold on here. Let me check Discord real quick. Oh goodness, I never check. Oh damn, you got it. Awesome. That's awesome. Okay. So Timey, what do you need help with? Let me check here. Right, I got you. You need oh my god, Timey, good thing you didn't buy this yet, because I'll tell you what you can get. You can get the Xenix 802 on Amazon or something $50, and that's what you want, okay? Like this is the mixer I have, and I've seen them. You can get them used for like $50. So it's Let me just give you this. It's called a Behringer. Sorry guys, I know. Thank you. You know what? I'll send it to you in Discord. Actually, I'll give you the name of the mixer and stuff like that. And I'll show you a picture here. There's the picture of the. Right there. So it's the Behringer. See, Behringer Xenix 802, and it's got 4 channels, but it has an effects channel, so it kind of has 5 channels, right? So it's pretty cool. But yeah, the Xenix 802, you can get these used, and that's what I'm using now. I was using the Scarlett 2i2, right? But that I gave to Ben. And then yeah, dude, this. Yeah. It's amazing. Yeah, I will add it. I'll send it to you in Discord as well, Timey, you bet. And Wilro, good morning, Wilro. Tell your wife Happy Mother's Day for us. No, it's actually really tiny. It's not that big at all. It's really small. It's like, I would say 8 inches by 10 inches. It's tiny, and like now that I can control the sound from my PC with the dial in front of me is amazing. Like I can separate the channels. It's so cool, right? So you got a mud mixer. Yeah, right on, dude. Wilro, nice to see you, pal. Sorry we gotta go, but glad you got the chance to pop in. And everybody, Vince and Jason and Timey, everybody, Christina, Eddie was in here. Aaron Banks, man, nice to see you. Everybody, thanks for coming. Ant Team Smoke was in. Haha was here. We had Chase. Chase was here. Chase. Who else? Oh yeah, Warrior Sister was in the house today, checking in. Warrior Sister of Justice. And I know there was another one. Dan Soderholm, of course, and Suhana. That's right, Suhana. A couple of new friends that we met in a creator stream networking session. It was awesome. No smoking other than a cigar. Pouring rain here. That's awesome, dude. Or can I work without it? Do you need headphones? You don't need headphones. You can do it through speakers. There's a way to do it through speakers, okay? Okay. Plus, there's adapters. Like, I don't have a free adapter, but there's different things I could show you, which, yeah, like there's cables and stuff you would need and stuff like that. But all depends on how you want to go. Like, if you want to put your voice through an EQ, then the mixer is the way to go. But if you don't mind just working off of the gain control and you don't want to go through an EQ, then there's the other things like the Rode, the USB thing, and then there's the Scarlett, right? But yeah, I think for the price of this Xenix unit, I would get it, hands down, get it over anything else. It's so much better. Yeah, you can use computer speakers. Like I was saying, there's just adapters you're gonna need to get, right? Which is the 3.5 millimeter to 1/4 inch, right? So you'll need mono to stereo, right? You'll need mono to stereo input. So mono 1/4 inch to stereo 3.5 millimeter. And then there's different adapters and cables you'll need, but yeah, it's really easy to do. It's awesome and it sounds awesome. So this is what it sounds like, right? So but I'll definitely help you out with anything you need for sure. But guys, thank you so much for coming. Timey, thank you for the message on Lutz. I appreciate that. And Brutus, it's 10 years old. That Brutus Crane. Oh dude, Taper John. That's right. The speakers will, like, they might. You have to be careful with the audio levels, right? If you have the levels too high, and the speakers will give you feedback. But you can plug regular, like the computer earphones. Honey, don't take that. You can take the. Oh, never mind. Okay, you can take the. You can plug into the computer speakers with things, but you'll see what I mean. You'll get it. But yeah, I gotta go, guys. Thank you so much for coming. I appreciate it so much. Happy Mother's Day to all you beautiful mothers out there. Lots of love to all of you guys. Thank you so much for coming. This is Chris, everybody. We'll see you on the next one. Bye for now.